There's something about speed that even when I should start at the moment, I want it to be fastest or faster than the timer. And there's something about speed that actually brings enjoyment. So even in the case of the small car like that, the option to hear the sound of the engine and even option to drive it brings some enjoyment. And fast things actually brings a lot of joy to all of us. And I truly believe that. And if you wish to have that enjoyment, I invite you to our booth after the presentation so we can also test it out if there's enjoyment in driving even the little car. But my presentation is not about cars, even though the truck will be there. It's about the speed and our need for speed in any projects, but today I will focus mostly on APA platform projects. So let me just really shortly introduce myself. I recently set up a Commerce Weavers company. For many years, I work for I'm still working as a core team lead at Cilius, so I actually manage people. I'm there with them to actually manage some stuff that we need to do and actually deliver better software for everyone. And one of the main projects that I'm doing is integration of Cilius and APA platform. And right now I'm also working on for the end customers on APA platform projects. And that's where the idea of it came to me that we should talk a little bit more about the need for speed in all the applications. But before I will jump there, let's ask a simple question. Why do we even need to think about performance? First of all, according to Amazon, every 100 milliseconds that we cut off from our website converts to 1% of revenue, which is huge in terms of hundreds of millions per year. If you can just, by simply reducing the time of it, can increase the sale, all of the CEOs, all of the management of the company will love you just because you brought more money to business. Another point, not directly related to cash, is that our lovely planet. So at the end, every time we are writing something not performant, we are using more electricity, more power of the computer, we are taking more stage, and at the end, it can translate to consumption of energy, therefore to fossil fuels, etc. So to some extent, being fast with the application may also mean that we are just more environmental friendly, which will be more and more important topic in the upcoming years. So with setting up the rules, why do we even need to discuss it? Let's start with our truck and what are the parts of it that makes our application slow. Before this conference, I did short survey over Twitter, LinkedIn, and on Slack, asking what are the biggest bottlenecks in our application. And you can see that a huge amount of people voted for database and the amount of queries, to be precise. There are some votes for cost of the object serialization and less about latency, so connections to the network and frameworks, which also may be a controversial idea, but in most of the application, your language framework does not count to the performance issues. At the end, the biggest problem that we usually have with the performance of our application is the cost of connecting to file system, to databases, etc., processing it, not how fast do we consume or calculate VAT or any other calculation on our project. And based on that, and we need to also discuss some basic principles. First of all, let's discuss algorithmic complexity. Now you will spot a few candies on the left bottom corner. It means that there will be a question for the candies that I brought from Poland. And if any of you would like to tell me what the algorithmic complexity is, you will earn one package. Anyone? Please. No one? Candies? No? Bribery? No? So, okay, I will answer for myself. I will have more for me. Algorithmic complexity is the concept from math that is discussing how the function is behaving when it is reaching infinity or its limits. So the point is that when we have algorithmic complexity big O of m, it means that it's linear. More items we process, the more things we consume to some extent. We can also have some other options of algorithmic complexity, so it can be logarithmic, it can be constant, so always we'll do the same amount of things. It can be O of M and N, then means that there are two factors that implies that are influencing the vectors, or there could be exponential growth, which means that with every increase, we exponentially increase the cost of operation. And to some extent, we can also use it in terms of measurements of the performance. The problem is that when we are on the left bottom corner of the slide or this graph, it doesn't matter which complexity do we have. With small amount of data, everything is fast. Everything works perfect in our local machine. The problem is when we are reaching actual limits of our application. So when we are moving with amount of elements to the right. Of course, the best options we receive with logarithmic or just constant complexity. Linear is also fine with the yellow, but then when we are going up, especially for exponential growth, we are asking for problems for the large data sets. And that's why, especially that so many people voted for amount of queries to be a problem, and because of the complexity, how we usually not think about it, I wanted to focus big chunk of this presentation about how we can reduce amount of queries. Because we usually forget about them as we are working on the small data sets. But to even be able to do, just small side note, please measure in terms of performance. The problem is that usually when we are just doing tests on the local machine, everything, as said, work perfectly fine, but we need to have measurements on the bigger scale to actually be able to deliver, to continuously deliver high performance. So this is important. This presentation is not about it, just wanted to mention. Another thing that is important is understanding your tools, which I will also partially cover in this presentation. Because tools are generally performant. Among us on this conference, there is Nicolas Grekas, who made the fastest router on the market among the PHP projects. So the Symfony project itself is fast, but it's generally fast. And when you are going to more and more edge cases or more and more complex project, you need to go deeper and deeper to native solutions sometimes, because they are providing their more to your use case. When you can be much more performant, you can actually sacrifice some kind of flexibility, some kind of readability, or how the project is extended to gain your speed. So tools are performant by default, but your projects are usually slightly different, and that's with the high scale, you need to go lower and lower. For the sake of this presentation, I created sample project. It contains only from 3 classes. We have an order. Order have items and can tell you the total of all the cart. The total will be calculated on a spot based on the order items that are there. Each order item has a quantity, product that it is related to, and the price, which is the quantity times price of the product. And there is a product with just name and the price. With all this setup, let's discuss database turn. So the thing that actually the most slows down our applications. Now, the first problem that I would like to discuss is n+1. This is not the candy question, but I have one spare. Who of you knows what's n+1 problem of database? Who of you would like to share? Please? Sorry, there is a mic coming on.
It's when it's related to lazy loading. Usually it's when you have a collection of something and you iterate over it, and every something you need to query, you query one at a time at the database instead of all your connection in the same time.
Exactly. So please join me after the speech. I will share you some sweets. Now it should bring you more involvement into the speech. The point is that when you have regular websites, like full stack ones, and we have the full templates, we can actually use much more of the lazy loading because we only read some part of data for each website. When we have the full API based and we have serializer, serializer will visit all of the fields and will initialize all of the relation that we actually have in that object for every request. It doesn't matter if you use it or not. Everything will be serialized at once in the default implementation. That's why n+1 hits us even more on API-based project, because of the serialization that touches everything that will be delivered to the customer. Now, for the product list, it's a simple object, as I told you, name and the price. We have 6 products. There are no association to other objects. Sample query, what you will receive is on the left. Who can tell me how many queries there will be to the database? That's not a candy question, but please. Yes? Okay. There was a 4. The truth is that it will be only 2. So the default AP platform behavior will ask a count and then for the object itself. There are two objects that will query. It doesn't matter how many products do we have. Therefore, we have algorithmic complexity of 1, which means constant. There will always be 2 queries. It may take a little bit more time on the database level, but still, we're only making 2 queries. Knowing that, let's talk about order list. Order list has one relation. It's to order item. We're asking just for 3 orders. Both of them are associated to order item units. Sample query on your left, which means that there is no total field. We are not touching any other any other details inside. So how many queries will be there here? 5. And this is, so David, you want also a suites, because I heard it first from you. Exactly, there will be 5, which comes 2 from the main, plus additional 3 to ask for order items, because we just serialize its IRIs. This is how, by default, IP platform works, which means that if we do not care about it, that we just increased linearly amount of queries, because more order items we will have, the more queries, more orders we will have, more queries there will be executed. This is the correct. Therefore, we have linear problem here. More orders, more queries to the database. But now, let's complicate the problem slightly more. Additional field. How many queries will be here? We have order, order item, and the product, and we are actually also including the total. So only one additional field in the output. Does any of you know? Can guess? Yes? Yeah, every product is different. Every product will be different, therefore, how you'd estimate it? There are 3 orders, 2 items, and everyone has different product. 11. Yes, exactly, 11. And that's how we are increasing more and more our complexity. So even though this is a super simple project, we almost skyrocket the amount, like to 11, of course, it's not skyrocketing, but the project is really simple. And yet we increased, just without our knowledge, the problems that are there. The question is how to spot the problems like that. Of course, we will see that our application is lagging on. But the main problem, or how we can use it, just with the pure Symfony, of course, Blackfire is a great tooling for that. But even with the simple Symfony, you can open a profiler, you can group statements, and if you will have increased amount of group statements, which means the same statement but just with different data, this is the perfect spot for you to think that there is n+1 problem, and you can do something about it, because you are, especially not on the local machine, when the database is slightly further from your application, you're increasing time to the processing time of your whole application. So how we can fix it? The first solution is straightforward. There are 3 different options how to fetch data: lazy, extra lazy, and eager. Is there anyone who would like to tell me what are the differences between them? Please. Sorry, wait for a mic.
I think lazy, they're not loaded until they're needed. Extra lazy is for collections, but like they still provide methods for like count and stuff. And eager, they're just going to be loaded at the same time as the object.
Yeah, so exactly, lazy will not touch the collection until we touch, will not load collection until we touch it. Extra lazy means that we can go further with that, and adding and removing will still not load collection, if I recall correctly. And eager is about the situation when we load all the data at once. So as you can expect, if we had 11 queries for the lazy case, we'll have also 11 queries for extra lazy case. For eager, finally we start reducing, which will provide us 9, because we still need to request all the products, because we need to put also eagerness between order item and product, which finally we are down to 5. And with adding additional serialization groups, so to be sure that nothing else is added, we can reduce it down to 4, which is nice. Right now, we almost have one third of the queries that will be executed, and especially that logarithmic that we are reducing it to linear problem again. So we'll not load as much data as we can. It will be, in terms of queries, reduce it to smaller numbers. The second solution that we can do is to actually extend collection query builder and add joins at the beginning. So our paginator will load all the data, so without touching eagerness or fetching option, we can define what will be defined here, what will be loaded together with the main object. The great point is that if you have a collection and you know that not all of the collection will be needed, you can add a condition here and it will only load the data that will be fetched from database. Again, this simple case can reduce amount of queries by half in our simple case. But the problem is that in the default implementation, I end up with having more data on the paginator than expected. And yeah, this is something that needs to be improved, so paginator needs to be extended further to actually compensate for the data that is returned by default. This third solution that is possible is to provide custom collection provider, which means it's a twist on the first one. So in the previous one, we just extended the default paginator and added joins to the query that it's there. But we can also take over it and just write our query as we want with the QL, and then ask for all the products. So inside will be almost the same query, but only this part will be executed. And this solution can bring us down to one query again, which is another linear problem. Therefore, from amount of the queries, it's constant, which is great. But in this simple solution, we are losing all the pagination features. So you will need to write pagination around it on your own to extend it or somehow. Because I didn't reuse the default paginator of API platform to be sure that there only one query will be located. So is the single query an ultimate solution for us? And also, things are not that simple. Otherwise, I will not make this presentation. So first of all, sometimes we cannot be that fast. Joins are expensive. More data we join, the query is bigger. We need to think about other indexes or other stuff that are on the database. This is the simplified solution. So, and not only joins are problematic, more data we load, the more hydration we will touch. Hydration is the process of transferring data from the database to application itself. So we have only 3 rows or 3 data about the product, then we need to fetch it. It will be some kind of array for some short time in the doctrine, and then with the magic of the hydration, we'll end up with the object. But this transformation is really costly. So more data we load, especially in one query, especially if we don't need that query, you hydrate more, which also hits your performance just on different angle. So we start reducing amount of queries, and yet we started to increase amount of processing that are needed on our machine, which is also not great. There's a joke about perfect size of microservice, which is as small as needed, but not smaller. And the perfect amount of queries is fetch as much data as you need, but not more. That's tricky, but the problem is that we need to actually balance, do not wait too much or do not depend on N+1 and lazy loading. We need to play with the queries. We need to go down to make it more performant. But we cannot say that joining everything is a solution, because it also increases other problems. It also creates another problems. And when we are creating objects, there's also a problem with proper definition. There are different kind of fields that we can define. Maybe something should be defined in an array or just JSON field in the database instead of the whole object. Or simple example that I wanted to bring to you is the float versus double or float versus decimal distinction. So decimal has a fixed point precision. Float has a floating point precision on the doctrine level, on the definition of the fields. Do you know what are the consequences of these differences? Anyone? Approximations. So one is will be stored as a float, which may end up as a problem with the calculation at the end in your application. The decimal is stored as a string, which has some particular consequences. Who of you would consider float to be a good option for latitude and longitude to define. This is the, okay, we have 1, 2. Okay, but will you store it on the database as a decimal or float? Decimal is stored with the precision in the database. Float has a floating point. Of course, we do not make calculation on the database level, but I encountered several projects that actually have decimal with the precise precision on the database level. The consequence is that we start something that is returned as a string to us, and we treat it as a float. And that's what this section is about. We have a product that has a float price and a float as defined on the database level. We are changing order item quantity, during which, for whatever reason, we are reading data inside of the product. How many queries will we have? How many update queries? Yes? So there will be only one, because we just update the data. So I'm only asking about update queries. Sorry, the question was not direct. There will be only one update to the database, because we're just updating one product item, which is super simple and straightforward. If I would change this float to decimal, how many update queries will we have during one transaction to the database? How many would you expect? We're changing one quantity on order item. Because I would expect the same result, only one update, which is not true. We end up with 2 queries because Doctrine is treating conversion from string to float as a change on the data. Therefore, he is updating data to the database, even though the data didn't change at all. And therefore, in this example, it's only one query. But if you have big object structure and you load 70 objects that have this particular issue, you have additional 70 update queries, which can significantly influence your application, which is just changing one field to another. And that's why it's important, especially for the bigger scale, to know your tooling. We need to be sure that, or we need to understand what's happening below. For the small project, we can probably skip it. But as we are going larger with the scale, we know details of how things under the hood works. So what are the fastest cars, APIs, that are custom? And further we go for the performance, the more native we need to go, the more customization we'll put there, because the default implementation will not suit us. Going forward to serialization twists. So basically, what we can do with serialization to improve our application. What I've noticed on several projects is that we're reducing network connections on expense of object size and database connections. One of the projects that I encountered had sent 15 megabytes of data just to read 2 fields, because the objects there were huge. There were only one read model for that, and we just need 2 data. There was no spare fields, so we loaded all of that at once, because people thought that it's easier to have only one read option for data and not make several queries or several representation. What we can do is we can introduce more atomic objects, which corresponds to edge-side APIs that Kevin Douglas talked about 2 years ago. So to have objects that are coherent within itself, but we can just reference other data by RAIs, which means that, for example, on the left side, we have a card that has items, and items have the products, because this is what usually you want to show. We need to the price, the image of the product, name of the product, etc. But on the other hand, some part of this data will be stored on order item anyway, like string, like name and the price. And we can still load images on the second query, or we can load it. The customer may wait for images on your website, even though, of course, it won't be perfect, but the main query will stay performant, which is important, especially for the connections or the customers that do not have perfect LTE or any 5G internet. And therefore, we're moving to the second part, which is partial serialization. Once we have we distinct main object of order to the product can be stored somewhere. Even on the local storage on the browser, we do not need to request for that. We can just load it instantly. Of course, the first query will be slower, but usually the products that we are exposing on the card are the products that were visited not long time ago. It's not always true, but I guess you got the point. So once again, with this example, we can have a product that will be just served to us as an IRI and then loaded directly from the local storage. And the third option that we can improve our serialization is to add also spare fields. So just do not ask for the fields that we do not want. Therefore, we'll also reduce amount of query because we will not touch all the objects that are there. Because with the amount of, with the increased size of the object, we increase cost of the query to the database and cost of the hydration. Now, moving on to our trait of good design. So finally, how we can improve the performance of our application. First of all, huge objects are a problem. The more data we have, the more things we need to fetch from the database, the more hydration or some kind of processing we need to do, which is also to some extent insane that, especially for the get operation, sometimes we are fetching something from the database, which was strings and numbers, then put it to the object just to translate it again to strings and the numbers with serializator. So we just make the full circle to the same state. And in the meantime, we just use two different libraries or two different projects that consume a lot of energy. We could just get it directly from the database and make some simple processing. But that's also quite extreme. But just let it sink to you that sometimes for the get operation, we're just using two things to have the same result as just skipping it. Now, to optimize it, we could have different representation. And it means that with the content negotiation, for example, we could adjust how it can work or how it can be presented. At least there is no super straightforward thing to have different representation of the object just by content negotiation. I mean, on the same API, same JSON API, if there is false, please, the API team correct me on this part, especially if I will fit with the time. So please do it. But I couldn't do it easily. Maybe something that we could hack on during the hackathon or just in the nearest days. The second part that we could improve is to minimize unnecessary operation. Once again, I move to the point that we put everything to one object or to one response because it will be needed on second page or on some stage of checkout, etc. This is not needed for most of the cases. And still, people tend to put everything in one request because it's REST. We have only one endpoint for the order details, so we'll put everything there. It's not a good solution. If you put available payment methods and shipping methods that are requested only on one page, make another request for that at this particular moment. So both objects will be also smaller, atomic, which means that they can be cached, for example, or they can be just asked at a particular moment when they are needed. Do not put too many things at once. We already learned that on the database or on the application level, GOT objects are a problem. Now we also need to learn that GOT APIs or GOT endpoints are also a problem. Do not put too much data into one. Now, there is also a shortcut that we can do here. So instead of having a problem with the database, we can have a read model shortcut, which would simplify a few things but complicate others. First of all, our IPA do not need to reflect one-to-one our entities or objects in the database. Or secondly, we can actually put more data or just split the data to more specific objects. So in this case, some put request to order may end up in updating our main order, and we can also update some daily bot items reference that based on that we can do some calculations, serialization, etc. We don't need to have only one object that is updated. We can split the processing to several ones or just have objects that are easier to read later. So I will continue operation in the order, but I also stored additional information in different stages that I don't need to process in other case. Secondly, what we can do is pre-compute. Who of you have ever used Cilius? Okay, thank you, some of you. I'm not sure if you are aware of what will happen now on this particular case. There are two pages. On the left, we have admin panel. On the right, we have a cart with this product in the cart. And this product costs $65.18, which can be seen here and here. This is exactly the same price. Now, who of you will know what will happen if I will update the price in admin panel? Let me show you. So if we'll go here and try to update the price and just save it, on the website, even if I will refresh, I still have the same price. It requires to click update button to finally have it recalculated. And this is the solution that we have already for 9 years. This is the amount of time that I am at Cilius, and it was previously. So no one actually was beaten by it. At least I didn't notice any problem. No one told me that pre-computation of these fields encounter any problems, even though there is some eventual consistency between them two. So I think that this is another approach that we could use more and more in APIs, is to saving some serialized objects. At the end, read models doesn't have to be models. We can store, if we have all the objects, we'll serialize it anyway because we'll serve it to the customer. Why not save it in the meantime and just then serve it from the key value storage, whatever it will be. I don't also encourage you to put too many things at once. It can be just Postgres that will have another table. You don't need to use entities or anything like that. Just read what is already serialized. Every time you will recalculate the order, you will just throw it out one object and then serve another one. There will, of course, it means that there will be no filtration on that, sorting, etc. It's not the purpose of this read model. The purpose of this read model will be just to present the data as fast as possible. So we don't need to have models like entities for our read models, and we can store pre-computed things in our database just to be faster. And just to sum up, who of you watched Top Gun Maverick? The repeated question that was there between pilots is not a plane, it's a pilot that makes the difference. And in terms of performance of our application, it's not the tooling, it's the developer who makes the difference. We can bring really plenty of speed to any application that we have. Of course, there is a question if it's worth it, how much time do we need to put their legacy projects are totally different aspect because it's already there and we need to brick by brick help it. But the main case that will improve our application performance are us, or we as developers, are the crucial ingredient to improve that. Outside of that, if I would like to leave you with some thoughts, is to remember about algorithmic complexity of your queries, because it will hit you really bad. So if you know that you will serialize some data and it's joined somewhere, put it at once. Just make one query, especially on the production application. You do not have everything probably stored in the one place. There will be also network connection or something like that in the local network. There, more queries you do, more time it consumes. Think about algorithmic complexity of your queries. Do not be beaten by n+1 or lazy loading. Secondly, even though you remember about queries, also do not hydrate too much data. There's another kind of the problem. So another part of equilibrium. And thirdly, think about out of the box of your entities. Not everything that you serve needs to be the full object, needs to be presented or have the same functionalities and lifecycle as anything else. APIs is one thing, your model structure is the second thing. In between, we can have data transfer objects, transformers from one to another that we can serve to the customer. API platform is already moving a little bit forward, domain-driven design and entities that are decoupled from data transfer objects. And this is also about thinking outside of the box of your entities. Your entity is not what you need to serve over the API. And that would also boost your performance. And with these 3 remarks, I would like to thank you very much for being for my presentation.